Hi, I am a tutor in Uplatz. Today we are going to discuss about FPGA designs with Verilog. One, introduction. Introduction. This full ladder is designed with the help of operators. Here we will learn following methods to create, implement the digital designs using Altera Cortex software, digital design using block schematics, digital design using Verilog codes, manual pin assignment for implementation, pin assignment using .csv file, loading the design on FPGA, converting the Verilog design to symbols, converting the block schematic to Verilog code and symbols. If you do not have the FPGA board, then keep the last part, that is loading the FPGA design of an FPGA. Simulation of the designs using ModelSim is discussed later. Cortex 2, 11.1 SP2 web edition and ModelSim Altera starter software are used for this, which are freely available and can be downloaded from the Altera website. All the codes can be downloaded from the website. First line of each listing here is this name of the Verilog file in the downloaded zip folder. Creating the project. To create a new project, first to open the Cortex and go to the file new project wizard as shown in figure 1.1. Create the new project. Introduction window will appear after this. Click next and fill the project details as shown in figure 1.2. Full ladder is the project name and location of the project. After this, add files windows will appear. Click on next here as we do not have any file to add to this project. Next, family and device settings page will appear. Select the proper device setting based on your FPGA board and click finish as shown in figure. If you do not have a FPGA, then simply click finish. Yeah, Cyclone is a family and the board also is selected and then finishes. After clicking on finish, the project will be created as shown in figure. Note that the data are tested on the D115D2 Cyclone 2 family or D0 nano boards. Therefore, project setting may be different for different chapters. You need to select the correct device while running the code on your system. This can be done by double-clicking on the device name as shown in figure. Update device setting if required. Digital design using block schematics. Digital design can be created using two methods, using block schematic and with programming language. Example, VHDL or Verilog, etc. Both have their own advantages in the design process, as we will observe in the later chapters of the tutorial. In this section, we will create the operator using block schematic method as shown below. For this, click on the file, new block diagram schematic files as shown in figure 1.5 and a blank file will be created. Create new block schematics. Double click anywhere in the blank file and a window will pop up and select AND gate from this window as shown in figure. Select the XOR gate. Select AND gate. Next, click on the XOR gate and then click on the generate pins for symbols ports as shown in figure. Now connect the input ports of the XOR gate and the AND gate using mouse, and then next right click on the AND gate and then click on the generate pins for symbol ports. Finally, rename the input and output ports as XY sum carry as shown in figure. Make connections. Finally, save the design with the name of added sch.bat. It is better to save the design in the same folder so that we can distinguish the user-defined and system-related files as shown in figure 1.9, where the Verilog codes are saved inside the Verilog code folder, which is inside the main project directory. Since the project name is full added, whereas the off-added design name is off-added schematic.pdf, that is not the same as the project name. Therefore, we need to set this design as top-level entity for compiling the project. For this, go to the project navigator and right-click on the operator sch.pdf and set it as top-level entity as shown in figure 1.10. Now we can analyze the file as shown in figure 1.11. If all the connections are correct, that analysis option will not show any error. Note that start compilation option above the analyze option in the figure is used when we want to generate this .sof or .py file to load the design on the FPGA, whereas analyze option is used to generate RTL view only. We will use compilation option in the next section. Manual pin assignment and compilation. Please enter correct pin location according to your FPGA board as shown in this section. If you do not have any in the board, then skip this section and go to the digital design section. Once design is analyzed, then next step is to assign the correct pin location to input or output ports. This can be done manually or using .csv file. In this section, we will assign pin manually. Follow the below steps for pin assignments. First, to open the pin planner by clicking assignments pin planner as shown in figure 1.12. Next, type the names of the pin and ports along with the pin locations on the board as shown in figure 1.13. Details of the pin locations are provided with the manual of the FPGA board. That is, example in D2115 board, pin ABA28 is connected with switch SW0. By assigning this pin to X, we are connecting port X with the switch SW0. After assigning the pins, analyze the design again. After this, we can see the pin numbers in the PDF file as shown in figure 1.14. Finally, compile the design using Control plus L button or by clicking process start compilation as shown in figure. After successful compilation, if you see the pin assignment again, then we will find that direction of the pin are assigned now as shown in figure 1.16. Where which was set to unknown during analysis as in figure 1.13. Load the design on FPGA. Follow the below steps to load the design on FPGA. Connect the FPGA to the computer and turn it on. Full compilation process generates the .sof or .py files, which can be loaded on the FPGA board. To load the design on the FPGA board, go to the Tools Programmer, and a programmer window will pop up. In the programmer window, look for two things. Position 1 should display USB blaster, and position 6 should display .sof file. If any of this mission, then follow below steps. If the USB blaster is missing, then click on the hardware setup location 2 in figure 1.170 and then double click on the USB blaster in the pop-up window location 3. This will display the USB blaster as at location 4. Finally, to close the pop-up window, if .sof file is not displayed at location 6, then click on add files at location 7 and select the .sof file from the main project directory or in the output file folder in the main project directory. Finally, click on the start button in figure 1.17 and check the operation of the operator using switches SW0 and SW1. Output will be displayed on the green LED G0, LED G1. Digital design using Verilog code. In this section, operator is implemented using Verilog code. For this, click on File, New Verilog file as shown in figure 1.5 and a blank file will be created. Type the listing in this file and save it as operator.verilog.p. Now set this design as top level entity. We can analyze the design now, but we will do it after assigning the pin using .csv file in the next section. Listing of the Verilog code for operator, command operator half underscore adder underscore Verilog dot B, modulo of adder underscore Verilog, bracket open, input wire A comma B, output wire sum comma carry, bracket close, semicolon, assign sum A XOR B, assign carry A and B and the module. In this section, we will learn to assign the pins using .csv file. Note that we use input ports as A and B in Verilog design instead of the X and Y as in figure 1.8, so that we can observe the changes in the pin assignment. To assign the pins using CSV file, follow the flow steps. First, type the content in figure 1.1 in the text file and save it as pin assign v.csv to assign file.csv to location A pin underscore AB 28, B pin AC underscore AC 28, some pin underscore E21, carry pin underscore E22. Next, click on the assignment. Import assignments are shown in figure and locate the file pin ACSJ file.csv by clicking on the C dots button. In the pop-up window, as shown in figure 1.20. Locate the CSV file. Now analyze the design and then open the pin planner. We can see the new pin assignments as shown in figure 1.21. If the proper assignment do not happen, then check whether the Verilog design is set as top level or not, and import assignments again and analyze the design. Finally, compile and load and check the design. Converting the Verilog design to simple, Verilog code can be converted into block schematic format, which is quite useful for connecting various modules together. In this section, operators Verilog file is converted into schematic, and then two operators is connected to make a full ladder. Note that this connection can be made using Verilog code as well. Follow the below steps to create a full ladder using this method. Right-click on the operator Verilog.v and click on create symbol file for current file. As shown in figure 1.22, it will create a symbol for the operator design. Convert Verilog code to symbol. Now create a new block schematic file, 1.5. Now next double click on this file and add the operator symbol as shown in figure 1.23. Again, add one more operator symbol along with OR gate and connect these components as shown in figure. Two and gates are operators are taken. Then the connections are done as shown in figure for the full ladder. Since one more part, that is C, is added to the system, therefore maybe modify the pin assign file.csv as shown in figure to location A pin AB28, B pin AC28, C pin AC27, some pin E21, carry pin E22. Update pin assignments, save the design as full ladder sch.pdf, import the assignment again and compile the design. See pin assignments as well for 5 ports, that is A, B, C, some carry. Finally load the design on FPGA. Convert block schematic to Verilog code and simple. We can convert the PDF file to Verilog code as well. In this section, full ladder design is converted to Verilog code. For this, open the full ladder sch PDF, then go to file, create, update, create STL design file as shown in figure 1.26 and select the file type as Verilog and press OK. And the file will be saved in the Verilog code folder. See figure 1.27 and the content of the generated Verilog file are shown in listings 1.2. Now we can convert this Verilog code into symbol. Note that if we want to convert the PDF file into symbol, then we need to convert it into Verilog code first, and then we convert the Verilog code into symbol file. Create the STL file for current file. Verilog code full ladder sch.v. Verilog STL is selected. Listing Verilog code for full adder, module, full adder, CH, A, B, C, sum, carry, input wire A, input wire B, input wire C, output wire sum, output wire carry. Wire synthesis wire underscore 0, wire synthesis wire underscore 1, wire synthesis wire underscore 2, off adder, Verilog B2B, instantiation dot of A dot of B dot sum synthesis wire of 1, 0, carry synthesis wire of 1, off adder, Verilog B2B instantiation 2, dot AC, B synthesis wire 0, dot sum dot carry synthesis wire 2, assign carry equal to synthesis wire underscore 1 or synthesis wire underscore 2 in module. In conclusion, in this chapter, we learned to implement the design using schematic and code method. Also, we did the pin assignment manually as well as using CSV file. Finally, we learned to convert the Verilog code into simple file and schematic design into Verilog code. Note, later, where some more details about symbol connections are shown, along with the methods for using the codes provided. Thank you.